The curve C has equation y equals g of x, where g of x is a cubic expression. Given that the coefficient of x squared is twice the coefficient of x cubed, there is a maximum at minus 2, 18, and the y-intercept is 2. So the fact it's a cubic expression is going to allow me to say that y equals something x cubed, I'll call it a for now, plus something x squared. Now I know that the coefficient of x squared is twice the coefficient of x cubed. So if the coefficient of x cubed is a, then the coefficient of x squared will be 2a. I don't know anything about the coefficient of x, so I'll just write bx for now. And the constant on the end, I could put plus c, but I do know that the y-intercept is 2. So I'm not going to put plus c, I'm going to put plus 2. I know the y-intercept is 2. Next, I'm told that there's a maximum when x is minus 2. So if I differentiate my function, I will get dy by dx is equal to ax cubed will differentiate to be 3ax squared. 2ax squared will differentiate to be 4ax. The bx will differentiate to be b, and the 2 will differentiate to be 0. And we know that that is going to equal 0 when the x is minus 2. So we'll substitute minus 2 in instead of the x. Minus 2 squared is 4, times the 3 is 12. So 12a. 4 times the minus 2 is minus 8. So we'll get minus 8a plus the b equals 0. The 12a minus the 8a is 4a. And we'll pause there because there's not a huge amount more we can do with that. The other piece of information, though, is I do know that when there is a maximum at minus 2, 18. So I know that the y-coordinate is 18 when the x-coordinate is minus 2. So if I substitute the 18 instead of the y there, and the minus 2 instead of the x is there, so 18 equals a times minus 2 cubed plus 2a times minus 2 squared plus b times minus 2 plus 2. The minus 2 cubed is minus 8. The minus 2 squared is 4 times the 2a is 8a. The b times the minus 2 is minus 2b plus the 2. You can see that the a's cancel out. So minus 2b is 16, so b is minus 8. Which I can then plug that in here so I can work out what a is. 4a plus b equals 0. So a is 2. So we can now substitute the a in here and here, and the b in there, and we've got our equation for g of x. So 2x cubed plus 2 times 2x squared plus minus 8 times x plus 2. That's our g of x. Part B says to find the coordinates of the other turning point. We know one of them is minus 2, 18. So to find the other one, we're going to differentiate this to get our gradient function. The 2x cubed differentiates to be 6x squared. The 4x squared will differentiate to be 8 x, and the minus 8x will differentiate to be minus 8. The 2 will differentiate to be nothing, to be 0. So my gradient function equals 0 at a turning point. And now to solve this, I'm just going to make my life a little bit easier because I can notice I can divide everything through by 2 there. And to factorise, it needs to be a 3x and an x to get the 3x squared. To get the minus 4, I think it's going to be a plus 2 and a minus 2. I think that way round, because that way I will have the 3x times the 2, which will be 6x. The minus 2 times the x will be minus 2x. And this gives me the 4x. So I know that x is either 2/3 or minus 2. The minus 2, I already knew about that point, so don't worry about that. That's the maximum point. So the 2/3 is the one I want. I know the x-coordinate is 2/3. To work out the y-coordinate, substitute 2/3 into the function. And if we do that carefully, 2 times 2/3 cubed plus 4 times 2/3 squared minus 8 times 2/3 plus 2 is, as a fraction, minus 26 over 27. And that is the coordinates of the other turning point.